Hey guys, let's take a look at this problem, MergeTwo Sorted Lists. I think we've done this before, but let's do it again. It's about MergeTwo Sorted Lists. Yeah, it's pretty straightforward. We can first try with a recursion way because merge two lists. Because we should do it with the inline splicing. Okay. Okay. Yeah, I've got done the recursion. So recurrence formula. How can I write the formula? Oh, I don't know. We just say we compare the first two nodes. I find the smallest one, so that's the root node we can return, and we just merge the rest. And when that is done, it will get another smallest one, so we can just set it to the next, right? So okay, let's say if the base function is that when there is no nodes, one of them is no node. So if L1 is null, return L1 2. If L2 is null, return L1. So there's no case of both of them being null. If L1 val is smaller than L2 val, so if that's the case, we will say L1 next should be merge two list. L1 next, L2, and return L1. In the other case, L2 next equals merge two lists. L2 L1, L2 next, return L2. I think this is done, so the first solution is recursion. Let's say what the time is. For the time, we find the smallest one, assign it, and get to the next one, and find the smallest and return it and assign it. So actually the time should be O n. Total nodes is n. So, but the space there is actually a call stack after this. So yeah, so there is a call stack, so it's also O n. Let's run the code. Finished. Accepted. Let's see how fast we are. We are not. Anyway, we are trying to do it in a recursion way. I think that the time could not be improved, but the space maybe we can avoid the call stack. So let's try to in iterative way. Iteration. This is still true. Okay, so for each, of course, we just find the smaller number and put it behind and update the next for each node. Okay, so we need to get the head first. So let's say head equals L1 val smaller than 2 for, we use 3 pointers. L1, if not, it's L2, right? Okay, we just can just use L1 and L2. So while L1 and L2, if both of them are there, finally we'll return head. If L1 val is smaller than L2 val, if it is smaller, then we'll update the linked list, right? So it's smaller than L1. We update. So next equals L1 next. L1 next should be L2. L1 equals L next. In other case, const next equals L1 next. L2 next. So L2 next equals L1, L2 equals next. So finally, some of them are done. Finally, one of them will end. So there will be some linked list left it at the end. So in this case, if L1 is still there, L2 next, because L2 is, wait a minute, L2 is null, so L1, oh, that's done because it's linked list. It doesn't matter here. Yeah, it's done. Submit. Oh, it's wrong. What's the problem? We get 5, 1, 2, 4, 1, 4. L1 next. Because in this case it's L2 is smaller, so L2 is next. Next to, thank you, X2 L2 next X X2 L1 L2 equals next, so 1 2, and then we will compare 4 5 and 2. What's the problem? We just log L1 val, L2 val to see anything wrong. got 5.1, 5.2, 5.4. Okay, so because this is L2 is 1, so 2 and next equals 1, 1, 5. Ah, it's not right. Shit. Oh shit. We should actually use another pointer. It's like 3 pointers, but because when we are changing, like swapping the like 1, 5, actually we're not pointing like 1 next is 5, but we use a previous node is point to 1. Yeah. Let p equals head. My bad. God. So actually is p next equals L1. L1 equals L1 next. P next equals L2. L2 equals L2's next. Of course, when it's done, P should be P. P is next. Something wrong. Yeah. Should pay more attention when we are doing manipulating linked list. Huh? What? Still not available? Head? Okay. Because L2 is smaller, so P next equals L2, and L2 equals L2's next. And P equals P's next. Okay, and then we check it again. L1, L1, L2, L2. Really? Five one. Because L2 is smaller, right? So P next equals L2. L2 equals L2's next. Why still 1? Said 5.1, 5.1. 5.1. Okay. But L2 is set to next. Five one, so smaller one here. What? 1, 2, 4. I'm confused. L2 equals oh shit. console log L2 go to next. There's something syntax problem seems to be. No. Let's run it again. Makes this one. Huh? I got it. Because at the very beginning there's no there will be no first node, so we have to create a node next. Like no, it's okay. No, use node head p equals head, and then p. Yeah, this should work. And at last, if L1 is still there, and p next equals L1. If L2 is still there, p next equals L2. This should work. Hope. Oh! Next. God. So, okay, so let's calculate the time complexity. Time. Every node is traverse once, so it's obviously on space. We actually use extra one node and one pointer, so it's actually O const. It's a constant. Submit it. Accept it. It's so slow. What? We spent 120. Wow, it's not even on the board. Wow, is that slow? It's crazy. Sometimes it's not unstable, so wow, it's so slow. Let's look at this how fast these guys are doing. Wow, no, it's actually the same. Anyway, you can the result here. Maybe I see. This if could be removed. Would it help? Even worse. What? Anyway, we'll stop here. See you next time.